Good day everyone. Today I will tackle all about the L'Hopital's rule. L'Hopital's rule states that its limit of f of x as x approaches to a equals to the limit of g of x as x approaches to a equals 0. Then the limit of f of x over g of x as x approaches to a equals limit of first derivation of f of x over first derivation of g of x as x approaches to a. Then we can say that the L'Hopital's rule exists. So we define L'Hopital's rule as a method of differentiation to solve indeterminate limits. There are two forms of indeterminate limits. First is the limit of f of x over g of x as x approaches to a equals 0 over 0. In the same manner, it has another form of indeterminate limit. Another is limit of f of x over g of x as x approaches to a equals positive negative infinity over infinity. Now, let's put in mind that in this theorem, it is only valid if and only if the limits are right-handed limits or left-handed limits. Now, there are steps in solving L'Hopital's rule. First, we have to prove that the given function is indeterminate. It could be 0 over 0 or positive negative infinity over infinity by using the limit theorem. Second is we differentiate separately the numerator and the denominator using first derivatives. There's a lot of rules and derivatives that we could use. Then the third step is when we apply the limit theorem on the new function. So apply the limit theorem on the new function which we used earlier, that first derivative. On this. Okay. Now, in case the new function assumes again the form of 0 over 0, the process may be repeated. So, after introducing the concepts of L'Hopital's rule, we will give you varied examples as follows.
Let's have the first example. Use L'Hopital's rule to compute limit of x squared plus x all over sine x where x is approaches to 0. First, we need to prove that the given function is indeterminate so that we can apply the L'Hopital rule. Here, x squared plus x all over sine x, we can apply the limit theorem. We substitute the value of x to this equation. Now we have 0 squared plus 0 all over sine 0 is equal to 0 squared plus 0 squared is equal to 0 all over sine 0 is equal to 0, which this is indeterminate. We solve this indeterminacy by applying the L'Hopital rule. Now we can apply the L'Hopital rules. We need to copy the function limit of x squared plus x is equal over sine x, where x is approaches to 0. Now, from this, we differentiate the numerator separately by the denominator. Now we have limit the derivative of the numerator, which is 2x plus 1 all over. The derivative of the denominator is cosine x, where x is approaches to 0. After getting the derivation, we can apply the limit theorem. We substitute 0 as the value of x. Now we have 2 times 0 plus 1 all over cos 0 is equal to 2 times 0 is 0 plus 1 is equal to 1 all over cosine 0 is 1. Now 1 over 1 is equal to 1. Now we come up that the limit of x squared plus x all over sine x, where x is approaches to 0, is equal to 1. That is the example number 1.
Our next example is evaluate the limit 1 minus cosine x over x squared, where x is approaching to 0. So we need to determine if this limit is indeterminate. So we need to substitute the value of x into 0. So 1 minus cosine 0 all over x, or 0 squared. So 1 minus cosine 0 is 1 over 0. So 1 minus 1 is 0 over 0. So this limit is indeterminate. So now we need to apply. Now we apply L'Hopital's rule. So 1 limit where x is approaching to 0, 1 minus cosine x over x squared. So we need to get the derivatives of this limit. So derivative of 1 is 0 minus the derivative of cosine is negative sine x over x squared. The derivative of x squared is that we need to apply the chain rule. So this will become 2x. So 0 times negative times negative. So it will become positive sine x over 2x. Then substitute the value of x to 0. So 0 plus sine 0 or over 2 times 0. So this will become 0, sine 0 plus sine 0 is equivalent to 0 times 2 plus sine 0 is also 0, so this is also 0 over 0, which is indeterminate. So we do not have since it is indeterminate, so we now again apply the L'Hopital's rule. So here. So again apply L'Hopital's rule. So this will become limit where x is approaching to 0, it will become positive or sine x over 2x. So we need to get the derivative of sine x. So the derivative of sine x is cosine x, and the derivative of 2x is 2. So we need to substitute the value of x to 0. So cosine 0 over 2 since we do not have x, so this will become 2. So cosine 0 is equivalent to 1 over 2. Then therefore the limit 1 minus, therefore limit our x is approaching to 0, 1 minus cosine x over x squared is equivalent to 1/2. So this will become now the answer.
Let's proceed to problem number 3. Limit of sine 3x over x minus 3/2 sine 2x as x approaches to 0. If we immediately substitute 0 to our given function, it becomes sine 3 times 0 over 0 minus 3/2 sine 2 times 0. Our numerator will be 0 and our denominator is 0. Then we get the limit of our function is an indeterminate form. To evaluate the limit of our function, we will apply L'Hopital's rule. Limit of sine 3x over x minus 3/2 sine 2x as x approaches to 0, we will get the derivative of our function. The derivative of our numerator is cosine 3x, and the derivative of our denominator is x minus 3/2 times the derivative of sine 2x, which is cosine 2x, plus sine 2x multiplied by the derivative of x minus 3/2 by the product rule. Then substitute 0, we get cosine 3 times 0 over 0 minus 3/2 times cosine 2 times 0 plus sine 2 times 0 times 1. Cosine 3 times 0 is 1 over 0 minus 3/2 is negative 3/2 times 1 plus sine 2 times 0 is 0 times 1 is equal to 1 over negative 2/3, or 1 times negative 2/3 is equal to negative 2/3. Therefore, limit of sine 3x over x minus 3/2 sine 2x as x approaches to 0 is negative 2/3. Sine 1 equal to